questions have been picked up directly from my book. Simple mathematics to find out the coordinates of this particular point. Look into this particular triangle, OAI. The question may not say thick glass lens. Thick word may not be there. The next statement of the question says, we will be able to find this angle of incidence. The students, you can see, hello friends, welcome back. As you can see on the board that we are going to take few problems on ray optics. These problems will be based on fundamentals. That means they will not involve any uses of some intricate formula, etc. They will be based on simple law of reflection or law of refraction or Snell's law, something very fundamental to ray optics. But before I take up those two problems, let me answer few of the questions which many of you have been asking on this channel. Some of you tend to believe that a question taken from a particular book or previous year question of JEE Advanced is going to be more helpful than any other question. Dear student, this is a totally wrong notion. A question is a question, wherever from it has been picked up. It doesn't matter actually. What matters is, by solving that problem, by doing that question, have you learned something new? Have you really taken some time to ponder over that question? Have you really struggled to find the answer? If that is the case, that means you have learned something. Many of you tend to believe that just by doing previous year questions or solving question from some specific book, like my book itself, will ensure a gateway, will ensure a selection in JEE Advanced. That may be true, but that is not the only way. The point is, if I have a question, solution of which is not very obvious, I should try, and by doing so I will learn something. So, wherever from, whichever source has been used to pick a question from, you should not be actually worried about that. You should just focus on the quality of the question. My aim in this particular channel is to feed you with some JEE Advanced level problems, problems which are appropriate to the level of JEE Advanced. Nothing more, nothing less. So, that is the message I wanted to give, and please let us focus on today's problems. In today's session, as I said, I will take up couple of problems from ray optics, and these questions have been picked up directly from my book. Okay, that is another thing, but here are two questions on ray optics. I will request all of you to understand the question and give it a try on your own, and thereafter see my solution. This is a curved spherical surface which is separating two medium. Medium on the left has refractive index mu and medium on the right is air. This is the principal axis of this curved surface is basically x-axis. Perpendicular to that I have marked y-axis. The radius of curvature of this surface is given as r. Then there is a beam of light which hits this surface from left to right, and this beam makes a very small angle theta with this principal axis, with this x-axis. The angle between the beam of light and the principal axis is theta. Theta is small, it is given to you that theta is small, which obviously means that you are allowed to use approximations like cos theta is equal to 1, sin theta is equal to theta, tan theta is equal to theta. Find the coordinates of the point where the rays will focus in air. Find the coordinates, that means x and y coordinates of that particular point where the rays are going to get focused after refraction. That is the question. It is no doubt a simple question, but I would request all of you to give it a try. Pause the video. Here I will do the solution for you. Students, for this, let us choose two rays. To fix the position of an image, two rays are always sufficient. So let us choose two rays in this beam which will help us in fixing the position of the image. The first ray is this one, and second ray is a ray that is passing through the center of curvature of the curved surface. So in this diagram only I will say that let this point be center of curvature of this curved surface, and this is the ray I am going to choose. This is my second ray. First ray is this one which is hitting the refracting surface at its geometrical center, and the second ray is a ray that is passing through the center of curvature of this curved surface. Now let us try to understand what will happen to these two rays. Where will this ray go? This can be calculated using Snell's law. In this particular medium, the refractive index is mu, and angle of incidence is theta. This theta itself is the angle of incidence, because this white line is nothing but normal at this particular point. So mu sin theta will be equal to refractive index of air, which is 1, into sine of theta dash, where theta dash is angle of refraction. We all understand that if a light ray is entering into air from some other medium, it will deviate away from the normal. This is the normal. So this blue ray is going to deviate away from the normal, and this theta dash is definitely greater than theta. As stated in the question that theta is small, we can write sin theta as theta and theta dash, sin theta dash as theta dash. When theta is small, theta dash has to be small. When angle of incidence is small, it is given that angle of refraction will also be small. So theta dash is nothing but mu into theta. So let me draw this ray, just tilt it slightly more. This is our angle theta dash, theta dash. Now what will happen to the second ray? This particular ray is passing through center of curvature, which means it is normal, the ray is normal to this refracting surface. So angle of incidence is 0. This ray itself is along the normal. This blue line is passing through center of curvature of the curved surface. So this ray will pass undeviated. So you can just extend this ray, and these two rays will meet somewhere in air, and that is the image point. This is the image point. Let me call the image point as I. This is our image point, right? Now, just a minute. Okay, this is my image point. Let us drop a perpendicular from image point onto this x-axis. Let me call this point as A. Now let us use simple mathematics to find out the coordinates of this particular point. This is what has been asked in the question. This is the image point, and we have to find the x and y coordinates of this particular point. So I think all of you will be able to do it on your own. So why don't you pause the video now and try doing it. Let us say this distance is x. Now look into this particular triangle OAI. Look into this particular triangle. If the height of the image is y, then I can write y upon x is tan theta dash. Y upon x is equal to tan theta dash. Am I right? Because of small angle approximation, I can write this as sin theta dash. So it is basically theta dash, which means this is equal to mu into theta. So y upon x is equal to mu into theta, which means y is equal to x into mu theta. Okay, that's fine. Now, again I will be writing the value of y in this particular triangle. Look into this triangle AIC. Look into the triangle AIC. Can you all see that this angle is theta? Yes, I hope so. So in this particular triangle CAI, again I will write, I'll change the color just to ensure that there is no mix up. Tan theta can be written as y upon x plus r. This is x and this is nothing but r, because C is the center of curvature. So again tan theta can be written as theta, and this is y x plus r, which means y is x plus r into theta. So this equation gives what value of y, this equation also gives you a value of y, these two must be same, these two values must be same. So just by writing that x mu theta is equal to x plus r theta, you will be able to calculate the value of x. Let us do that. Let us do that. So x mu theta is x plus r theta. Theta cancels out and you get the value of x. This is r upon mu minus 1. So you have got the x coordinate of this particular point, isn't it? And the y coordinate can be simply obtained by substituting this value of x here. So this way you have been able to calculate the x and y coordinates of the image point. So this particular question does not use anything other than Snell's law and simple geometry or trigonometry. Many a times in the past also, there have been questions in JEE Advanced paper where maybe you are seeing a prism or some odd shaped medium, but the question only required the knowledge of Snell's law and some geometry or trigonometry. So please be careful when you see a prism in a JEE Advanced question paper. The question may not involve any of the equations that you have memorized regarding the prism. It may be that the whole question can be solved just on the basic concept of Snell's law, maybe the concept of critical angle. So please always be careful and rather be ready to apply simple fundamentals rather than trying to use some memorized formula, etc. Let us move on to our next question. This question says that this is a thick glass lens. The question may not say thick glass lens, thick word may not be there. The next statement of the question says at the center the lens has a thickness of 2 centimeter. At the center the lens has a thickness of 2 centimeter. Whenever a question is saying that thickness of this lens is blah blah, you should always be careful whether you are allowed to use all the lens formulae that you have memorized, because all the lens formulae that you have memorized are valid only for thin lenses. Thin lenses means those lenses for which we just ignore this distance. But this particular question is specifically telling you that thickness, so you may not ignore that thickness, right? So maybe the lens formula that you have memorized is not applicable here. So the question says that this is a thick lens having a thickness of 2 centimeter at the center. The refractive index of medium on the left is mu, refractive index of the medium on the right is 3 mu, and the refractive index of the material of the glass is 2 mu. Now there is a light ray incident on this lens and it hits the first refracting face as shown in the figure, inclined at an angle of 2 degree with this optic axis, right? So the incident ray makes an angle of 2 degree with the optic axis of the lens, and the question says find the angle that the emergent ray will make with the x axis. What angle the emergent ray will make with the x axis? It is given that both the surfaces have radius of curvature equal to 10 centimeter. So at what angle the final emergent ray will be going with respect to the x axis? That is the question. I urge you all to pause the video, give it a try. Here I am solving it for you. Now because I have realized that this is a thick lens formula, how do I realize this? This is 2 centimeter and the radius is 10 centimeter. I just cannot say that the radius of curvature is too large compared to thickness of the lens. So I just cannot ignore 2 centimeter with respect to 10 centimeter, and therefore I will have to take cognizance of this, that this lens is actually a thick lens. So the formulae that I have learned may not be applicable. I am not going to apply those formulae. Then what am I left with? What am I supposed to do? Simple fundamentals. What are those fundamentals? Snell's law. Ultimately, the lens formula that you have memorized is obtained by considering refraction at the two surfaces, right? So, the same thing, the refraction at the two surfaces have to be considered here to answer this question. Let us consider the refraction at the first phase, at the first refracting surface. If we apply Snell's law, what do I get? Here I will write refractive index into sine of 2 degree. This will be equal to, the light is going in a medium of refractive index 2 mu into sine of R1. R1 is the angle of refraction. So, obviously 2 degree is a small angle and we can use a small angle approximation. I can write mu into 2. Actually, I cannot write sine 2 degree as 2. I will have to convert 2 degree into radian and then that value should be written here. But okay, it does not matter in this case because on both the sides I will assume the angle to be in same unit. That means I will be getting value of R1 in degree unit only when I am taking this in degree. When I am writing this in radian, I will get a value of R1 in radian. So, the conversion factor remains same on both sides, so it does not matter. I will just write 2 degree 2 mu R1. So, R1 is actually 1 degree. So, what happens when the light travels from this medium to this medium, the angle of refraction is 1 degree. Now, this light ray will be going somewhat like this. This angle is 1 degree. So, now let us consider the refraction at the second surface. Let us focus on what is happening on the second surface. I will draw a separate diagram to consider that. This is the second surface that I am showing. I am not showing the first surface, this is the second surface, and the situation is somewhat like this. Look here, the light ray that is incident on the second surface is making an angle of 1 degree with that particular x axis. So, I can show my light ray going like this. Just to keep the diagram clean, I will draw it like this. 1 degree is this angle, very small angle. So, this light ray is again going to suffer a refraction. It is moving from a medium of refractive index 2 mu to a medium of refractive index 3 mu. Am I right? The question says that both these surfaces have a radius of curvature of 10 centimeter. So, for this surface also, the radius of curvature is 10 centimeter. That means this length OC is basically 10 centimeter. This length OC is 10 centimeter. And if I want to draw normal at this point of incidence, what I need to do is I will have to connect this. This is the normal. So, now let us find the angle of refraction here. Again use the Snell's law. So, what is angle of incidence here first of all? So, the angle of incidence as you can see is this angle. Let me write it as I. It is not 1 degree. It is not 1 degree. So, the first thing that we need to do is we have to fix the value of angle of incidence. How can we do that? Can you understand how far this point is from O? Again, you will have to go back to the first diagram. This is the point I am talking about. This yellow dot is the point from where this ray has been shown like this, but that means this ray is intersecting the x axis at this particular point, and this particular point is at a distance of 2 centimeter from this point. So, this ray, this blue colored ray is intersecting the x axis at a distance of 2 centimeter from point O. So, this is 2 centimeter. This length is 2 centimeter. Can you see that? So, now again using simple trigonometry and geometry, we will be able to find this angle of incidence. The students, you can see that if I take this angle to be theta, this length obviously is very small. This is 1 degree angle, right? So, I can write tan of 1 degree is equal to this height upon 2. Let me call it as y upon 2. This is y upon 2. And similarly, tan theta can be written as y upon 10 because this distance is 10. So tan theta can be written as y upon 10. So you can easily see that basically this theta is y upon 10 and this angle, whatever it is in degree measurement, it is 1 degree. So this equation is not actually correct. I should write it in radian, but please try to understand what I am saying is for y by 2 it is tan 1 degree. So for y by 10 it is tan 1 by 5 degree, isn't it? This angle is 1/5 of this angle. If tan 1 degree is y by 2, or let me write it as I only, not 1 degree की जगह मैं इसको I लिख देता हूँ. So yes, I is in radian unit. I is equal to y by 2. Then what do you see? Theta is actually I by 5. So naturally you understand that theta is 1 degree by 5. So this is 0.2 degree. So this angle is 0.2 degree. Now this angle is 0.2 degree. This is 1 degree. Now can you see that this angle of incidence between blue ray and this white ray is actually equal to 0.8 degree. So the angle of incidence here is nothing but 0.8 degree. This is 0.8 degree. 1 degree minus 0.2 degree, because this 1 degree is this plus this. Exterior angle is sum of two interior angles. So angle of incidence now is 0.8 degree. Now if you apply Snell's law, you will get angle of refraction for this light ray. So again applying Snell's law, 2 mu into sine of I, which is 0.8 degree, will be equal to 3 mu into sine of R2 or R, whatever you write it. Angle of refraction has been written as R. So this time it becomes again the conversion factor from degree to radian remains same. So I can take a slight liberty and write it as this thing. So R is equal to nothing but 1.6 by 3 degree. Am I right? 2 into 0.8 by 3. Okay. So this is the angle of refraction. But question is not asking this actually. What the question is asking is, you have to find the angle that the refracted ray makes with this x-axis. So now it is a simple geometry, you all can do it. What we have found is that with respect to this line, this blue ray after refraction, which is very difficult to show actually because it has got even closer to this line, this is R, 1.6 by 3 degree, this angle. So with this horizontal line, what angle does this ray make? So you can find it out because this white ray is making an angle of 0.2 degree. Can you see that? This white line is making an angle of 0.2 degree with this line, with this particular line. So this green line I have drawn is parallel to this line. So with this line it is 0.2 degree, and from 0.2 degree now you have so many degrees here. So 0.2 degree should be added to this number to get the exact angle that the emerging ray will make with the x-axis. Students, I hope you have understood these two questions. They were more of geometry and observation skill, rather I would say. They were based more on your observation skill rather than some intricate use of formula, etc. So thank you. See you in the next video.